Okay, let's see how well I've managed to get this working. Now I can see everything. That is good. Yeah, okay. I wonder if I know if I know. Just get started. Yeah. So, seam carving. This is an experiment for me. I've never done this before. Uh, My handwriting is much bad. Nah, and what's the date today? So, content aware image resizing. That's our basic problem. We need to resize images such that the main ideas don't vanish. Like, for example, in this one, I can't see my cursor. Hmm. Yeah, okay. I mean, I understand this thing. Okay, so a seam is a connected path of low energy pixels in an image. On the left is the original with one horizontal, one vertical. And in the middle, I think the first one is the energy function and vertical and horizontal path maps. Okay, so this is the energy function, this thing. So they've calculated it by some method, and using this energy function, they have found these places in the image through which there is a lot of energy, in which there is a lot of energy, or something like that. So basically, the seam has to sort of pass through this zone. And if you look at so I think so this is the horizontal seam map, because the triangles are facing the the XY direction, and the bottom one is the vertical seam. Sorry, what do they call it exactly? Path maps. Okay, fine. Yeah. So in this one, you should probably go somewhere like this. Is one. Wonder what that corresponds to here. Maybe one line like this is what they mean. Something like that. But there's a cloud over there. So this cloud is what I'm talking about. So, you pass like this, something like that. So, yeah. And now, okay, so on the right hand side, they've shown that they've extended in this dimension and they have contracted in the other dimension. Okay. They've inserted seams as well as removing seams. Yeah, so we can look at this. So the bottom picture on the right side is what you would get when you just normally scale an image. It looks very elongated on one side and squished on the other, whereas this one looks quite identical to the original image. Not identical, it doesn't seem like there is a lot of manipulation done to it. So I think that is the result. Let's read the abstract. Effective resizing should not only use geometric constraints but consider image content as well. We present a simple image operator that supports content-aware resizing for both reduction and expansion. Okay, seam is an optimal 8 connected path. So what is an 8 connected path? If this is the middle pixel, a 4 connected path would consider as neighbors only these 4 pixels around it. So if this was how the image looked, and if this was the middle pixel or the pixel of interest, a 4 connected algorithm, or any 4 connected technique would consider only this guy, this guy, this guy, and this guy as the neighbors of the center pixel. Whereas for the 8 path, so 8 connected path, let me draw a little bit bigger. You have all 8, maybe not the middle, please. That is a central pixel. So this is what they mean by 8 connected path of pixels on a single image. So a seam is an optimal 8 connected path of pixels on a single image. So what they mean is, when they have to look at neighbors, they're going to consider all 8 pixels. They're not going to discard. They're not going to remove the corner pixels on a single image from top to bottom or left to right, where optimality is defined by an image energy function. By repeatedly carving out or inserting seams, we can change the aspect ratio. By applying these operators in both directions, we can retarget. Selection in order protects the content as defined by the energy function. Okay. Okay, so I guess the important stuff here is one, the definition of a seam. So get a color. Where is this gone? Yeah, a seam is an optimal 8 connected path of pixels on a single image from top to bottom or left to right. So the first thing is they change the aspect ratio of an image, and then second thing is the selection and order of the seams protects the content of the image. So I believe selection is done by looking at the energy function, and I think by order of seams they mean what seam should be removed first. I think the one with the least energy or most the least energy should be removed. We support seam carving can also be used for content enhancement and object removal. Okay, interesting. We support various visual saliency measures for defining the energy of an image and can also include user input. By storing the order of seams in an image, we create multi-size images that are able to continuously change in real time. Okay, I think this is probably very important because so what you can do is I think what they mean here is there's some place. Okay, yeah, so suppose I have, there's a pen, suppose I have this image, and if someone tells me beforehand that this is X, this is Y, if someone tells me they want to make it this size and I know X prime and Y prime beforehand, I would remove X minus X prime number of seams from I would remove X minus X prime vertical seams and Y minus Y prime horizontal seams. That is pretty simple and doable. But what if you had an image, let's get rid of this guy. What if you just had an image and you didn't know what was the target size? So instead, there are these pins at the corners which you can see in many image processing softwares, and you can just drag one of these corners and extend the size and the basically the width and the height. So imagine if you could do that. So in that sense, the person who is dragging will not tell you beforehand when is he going to stop, when are they going to stop dragging. So you need to so you need to work on that case as well. So what they have done is, so for every single so where is this guy? Yeah, so suppose the next enlargement is this for the image, from X to just X plus 1. So they've stored an order of the seam in you can just store it somewhere, saying that for width X plus 1 you remove this seam, or you have a seed somewhere here from which you make a seam and you just store the location of the seam here. I think that's what they'll go with. That's like the first idea that I am getting. I'm reading the paper for the first time. So that is there. And so similarly for X plus 2, X plus 3, so on, all the way to, I guess they are going to stop somewhere. And then in the other case, on the other side of the other side of the table, this is X, so you remove 0 seams. What about reduction? X minus 1, X minus 2, X minus 3, so on, so forth. Until, I guess this has limit. You can probably say until X minus X, which is 0. And similarly for the Y direction, if you basically store these two arrays, and you can basically do multi-size image retargeting. So that is there. I think that is what they mean by multiple. So that's what they said, by storing the order of seams in an image. Okay, so not only do we have to store the seam location, the starting point of the seam, you also have to store like the order in which you're going to remove. So it's probably a little bit hard. What are you going to do? 2D hash map. Yeah, you need something of that sort, because I think there is going to be some other rule, because you can also, you can, what if you have to remove a horizontal and a vertical seam at a time? Which one are you going to remove first? So you basically might, in your array, you might need to have a chain or something where, where, for example, for this location, you have, my arrows are horrible. Yeah, for this location, you have seed, the starting point of seam 1 and in this direction. And then the starting point of seam 2, but in this direction. Then the starting point of seam 3, this direction, S4 in this direction, then maybe S5 in this direction. Yeah, maybe that is something that we have to do. So, yeah, that looks about what I think is being done here. Let me just erase this. I would rather have some sort of better way of writing all this down. Get rid. Oh my god, this is so slow. There should be some way to increase the size of the eraser, but this is a good size for when I'm writing, because my handwriting is small. So okay, so basically these are three important things. We know what a seam is now, and then we know how they're removing the seam by using the energy function, and then they think that the selection and order of the seams is important, and then the last thing is multi-size. So yeah, I think multi-size is probably going to be a bit hard. What the hell? Multi-size is probably going to be a bit hard compared to the others. Multi-size store seam and direction in an array for all possible values of widths and heights. Yeah, okay, makes sense. Now let's go on. This is going to be a bit of a log. The diversity and versatility, blah 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 blah. Yeah, so this is what they mean. Support dynamic changes of page layout and text. So if you have a page on a desktop and you have something here and some other stuff here, and if you change it to mobile, it's just this part is going to transfer here. Usually that's what happens, and all this is going to content aware. This is basically content aware moving around. This part is going to go either above this or below this. So yeah, I know this because this is how it works on my website. I basically have text in the middle, and I have contents over here, and I have the what's it called, the navigation bar, I guess. I have that here. This is how it looks on the desktop, and then you move to mobile, and this is a screen content initially, and then there are the contents go above. So this stuff goes above, and the nav bar goes below. I mean, I don't know how to specifically make stuff like this, but yeah, that's how this, that's what they mean by dynamic changes. And they say that images are not doing this very well, is what their concern is. This is an old paper, by the way. When they released it. Sorry, I think 2000. Let me check. Seam carving. Seam carving. When was this released? Okay, 2012 is what? No, It's not possible. Uh, I don't know. Okay, I mean, just wait. I just want to find out when Seam Carving was released. Wait, I don't think you guys can see what I'm doing. Yeah. So Seam Carving was released Yeah, I mean, this is a famous example of seam carving. 2007, ACM SIGGRAPH. Wow, that's a lot of time, 15 years. Unreal. So, yeah, okay, let's get back to our thing. So, yeah, this thing was released in 2007. So, I mean, but it's still a great paper. I just want to write this down so that I don't forget it. Yeah, back to my favorite color. So, other cases in which the size or aspect ratio of image fit into different displays. Okay, standard image scaling is not sufficient since it is oblivious to image content and typically can be applied only uniformly. What does that mean? Typically can be only applied uniformly. I wonder what that means. Cropping is limited since, yeah, I actually want to know what that means. Ask someone. Okay. Cropping is limited since it can only remove pixels from the image periphery. That's true. More effective. Yeah, so what they're saying is, like, first of all, if you just normally scale it, it's going to squish certain stuff and elongate certain stuff, etc. It's not going to do it in a good manner. And then if you just try to crop it to resize it, you're going to lose lots of information because cropping is just snipping away stuff. So yeah, more effective resizing can be achieved by considering image content. We propose a single image operator, the term seam carving, that can change the size of an image by gracefully. I like this word over here. Yeah, I mean, I wonder if papers were written a bit differently back then, or inserting pixels in different parts of the image. Okay. Seam carving uses an energy function defining the importance of pixels, connected path, crossing the image from left to right by successfully removing or inserting seams we can reduce as well as enlarge. Okay, this is the same stuff written again. Image reduction, seam selection ensures that while preserving image structure. Yes. So yeah, so basically this is the objective function, while preserving image, sorry, remove more of low energy pixels. For image enlarging, the order of seam insertion ensures a balance between original image content and artificially inserted pixels. For image enlarging, the order of insertion ensures a balance between the original image content and the artificially inserted pixels. Okay, I mean, I don't understand this as well, but let's go ahead. Wait, what? Yeah. But aspect ratio change, image aspect ratio change is, like you have a certain 4:3, you want to change it to 3:2 or something. That is aspect ratio change. It is not very different from image retargeting. It's another way of saying the same thing. If you have 4:3 to 3:2, or if someone says, they have a image of size 120 by 90 and they just want to make it okay, nice, 105 by 70. I think that works, right? 3 times 2 and 4 times 3. Yeah. So this is the same thing as image retargeting. It's no different from what we were doing all this while. So yeah, these are just the same things said differently. We don't have to, I guess you would like them to be different tasks, but fundamentally they are the same. For aspect ratio change, image retargeting, content enhancement, and object removal. Okay, let's see what those are. They probably explained in the paper. Furthermore, by storing the order of seam removal and insertion operations and carefully interleaving seams in both horizontal and vertical and horizontal directions, we define multi-size images. Yeah, this is the same thing what we discussed. Such images can continuously change the size. A designer can author a multi-size image once, and the client application, depending on the size needed, can resize the image in real time. Yeah, so this is something that is important to us as well when we are going to be implementing this. So I think what we want is to first so basically I'll just write this down here because I know I started it over there. We need to give them the image and we need to send them the array of these values of widths and heights, and both of these combined form a multi-size image. So probably when we are implementing it, one thing that we should do is, have like, what are those things called? Like, you can change output. Like Jupyter has some GUI that allows us to change inputs or, specify outputs where we can have a slider or something like that. And this goes either way to tell us what's the size, and the image should change in the output. Yeah, so this is something that we should probably do as well. So we should keep that in mind. So the basic idea is the image and the array with all these things, that we pre-compute makes the multi-size image. Okay. So seam carving can support several types of energy functions. Gradient magnitude is one, entropy, visual saliency. I think visual saliency is something to do with the first thing or the most important things that humans look at in a image. Let us check that as well. Visual saliency. I keep forgetting to switch windows. So yes. Yeah, it's the subjective perceptual quality which makes some items stand out from their neighbors and immediately grab attention. Let's look at this for a while. I can't believe it linked to the PDF. Thought it was abstract. Okay. Yeah, so like if we take a look at this stuff, yeah. What? So if we take a look at this stuff, I guess when we as humans immediately look at these pictures, I guess this is the kind of stuff that stands out to us. Like that's the first thing we're going to look at. The saliency maps in the bottom row are telling us, what's the first thing that's that we are going to look at when we look at these images. I don't know, probably don't agree with the first one. I looked at the black one, the black cow in the beginning, but for the others, probably, yeah. Uh, yeah, and this one as well makes sense. This is probably true. So let's look at some more examples if there are any. Yeah, this is another one. Yeah, this is a big paper. This is a survey paper though. So, I probably outscored the, yeah, it's there. Okay, so good. Yeah, in all this, we can see that these are the stuff that catch our attention. So I particularly like this result because it even shows the fact that, like some of us would like to read what's on that. So this result actually shows that as well. I don't know if you can see. Yeah, you can. Okay. Yeah. So yeah, I mean that's enough digression. Let me go back. Uh, yeah, we're back. Yeah. So yeah, that was visual saliency, eye gaze movement. I'm not sure how they're going to model this stuff. So yeah, it's none of my business right now. The removal or insertion processes are parameter free. However, to allow interactive control, we also provide a Scribbleways user interface for adding weights to the energy of the image and to guide desired results. Whoa, what? Scribbleways user interface for adding weights to the energy of an image and guide desired results. This tool can also be used for authoring multi-size images. Probably this is something that's important, so I'm just going to just going to ask someone about this. What do they exactly mean? My hand is so wobbly. Yeah, okay. So to summarize, our main contributions are as follows. Define scene carving, present the algorithm, use it for that, blah blah blah. Yeah, I mean we've covered all that. We're good. Image resizing is a standard tool. I don't want to read any of this. Let's see if there's anything important. I'm going to skim super fast. Hey, I recently learned about this. Oh, this is not. Automatic thumbnail creation. The large image is then cropped to capture the most salient region in the image. Okay. This is probably literature review. I am not going to read everything. Okay, so yeah, so basically this is what the author wants to say in the end. All these methods achieve impressive results, but they're all just resizing and cropping. Yeah, okay, I'm done with that. I don't want to read any of that stuff anymore. Um, Results of five different strategies for reducing width of an image. Original image and its energy function. Not sure if this is properly visible, but yeah. So the energy function to me looks like a some sort of edge detection thing. At least from this energy function. Best cropping. Okay, this is probably one of those things that was written over here. I kind of think I saw best cropping somewhere. Yeah, so best cropping, you can see it gets rid of lots of stuff, I guess. And this entire thing is gone. Like if you look at best cropping, uh, this entire thing is gone from here. Okay, wait, we're looking at cropping. Sorry, yeah. This entire thing is gone, as well as this entire thing is gone. Yeah, in a way. It's not exactly gone though. It's sort of, it looks compressed to me, more like. But anyways. Oh no, I just keep forgetting. This is not crop, this is column. Yeah, so in crop, they basically, just cut out these two parts. That's what they did for crop. So, and then column is removing columns with minimal energy. So I guess, a column is basically a one line through the image with minimal energy. A straight line from top to down with minimal energy is what I think a column is. So as you can see, I mean, I think this is a kind of a, if the image had more of horizontal detail, like for example, if you look at the what is this called? The step, the marble step thing. You can see that there are like so many artifacts generated over here because of the fact that they're just taking out single columns. I keep losing my cursor. Where are you gone? Oh, you're here. Yeah, because they're just taking out top-down columns, so there's so many artifacts generated. And yeah, I'm just checking if I didn't undo too much. And then the next one is seam carving, which they say is the best thing because you can actually see that it's kind of much better than at least column. There are no artifacts in the bottom, and we have most of the detail. But I mean, we have most of the important detail. Even though if you look at one thing, column preserves this part of the image to the in the box that I'm drawing. So column preserves that, even though it makes it very small. But seam has like sort of completely gotten rid of that thing. Yeah, but I guess that's all right because the as an image, it's looks pretty good. So and yeah, I mean, I guess you can probably figure out why E and F look like that. So they've taken so in every single row, they have just found the minimum pixel, and they've just gotten rid of each of these minimal pixels. So obviously, it's going to create like lots and lots of artifacts because you need if you have an image like this and you remove one pixel here and one pixel here, the image is going to go one pixel down, but it's going to be very haphazard. Maybe there's a guy over here, and you've gotten rid of his face or something like that. So now I get that it's not a very good analogy, but yeah. Anyways, yeah. So that's the reason why this thing is happening, and and the final one is just forget rows, just pick out all the pixels with low energy and just start removing them. So yeah, I wonder if it'd be kind of fun to implement this as well. So yeah, yeah, I mean, I would love to actually implement this. So, just to check how it's gonna look for different kinds of images. Then the operator, the our approach to content-aware resizing is to remove pixels in a judicious manner. Therefore, typo. Yeah. Mm, yeah. Okay. I'll probably continue again next time from the operator. We've gotten a good deal of, a good idea of great deal of stuff. Even though it's not like anything substantial, but yeah, I think this should do good for now.